Hey everybody, so this video is actually to a couple different reasons. We're going to actually quiz you on a couple of things that you learned already, and then we're going to preview what you're going to learn on Thursday and Friday. So the first thing is this, and during the course of this video, please pay attention because we are going to, it is going to assess you, and we're going to give you some quiz questions, and we're going to grade you whether you're right or wrong, not whether you do it or not. So please remember, you could always go back and you could watch whatever part of the video you want. You just can't go forward. All right. So the first thing is just to warm up, something we've done in class. The question I want you guys to answer is if you were to actually write another equation. If I wanted there to be no solution, I might write something that says this: negative 4x minus 5y. And I don't think you could see that very well. Equals, and then I would make it like 10, say. Because, when you do elimination, both the x's and the y's are going to cancel out, and you're going to be left with 0 equals 20, which would have no solution. What I would like you guys to tell us is if you wanted there to be infinite solutions, okay? And that means we need the same equation. What I'd like you to do is if I were to write another equation, I'm going to just make this up. I'm going to say that this one is definitely going to be 12x. This one is going to be 30. What I'd like to know is what would this value of y, what would the coefficient in front of y be in order for this to have a infinite solutions? Okay. So hopefully you got a chance to answer that question. And what you're going to notice is that to be infinite solutions, we need to make both these equations the same. And to do that, you just have to multiply or divide by the same amount on both sides. So I noticed that 4x times 3 and 10 times 3 is 30. So all I'd have to do is write a 15y. And by doing that, I just multiply the entire equation by 3. These two are the same equation. Therefore, they're going to have infinite solutions. So this is just a reminder of what you learned today. In order to, this is a inequality with two variables. So there's a lot of things that might make this work. You could plug in a bunch of y's and x's and just see if it works. Like, for example, maybe 3, 2 is a solution. And to check it, I would put in a 2 here and a 3 here and see what each side gets. So this side already says 2. This is, negative 3 times 3 is negative 9. Negative 9 plus 4 is negative 5. And sure enough, 2 is greater than negative 5, which means that 3, 2 is part of our solution. But if you want to see all the solutions, remember we learned in class that you're going to graph the line as if it said y equals negative 3x plus 4. So there's a point right here at 4. And then the slope is negative 3, which means I'm going to go down 3 to the right 1. 1, 2, 3 to the right 1. Down 3, 1, 2, 3 to the right 1. And then remember, now it's either going to be a dotted line or a solid line. Because it says and equal to, it's going to be a solid line. And then the last thing is, remember, the trick we learned is that if you solve it for y and it says y is greater, that means all the shading is going to be above the line. So all the shading's right here. And you're going to notice that 3, 2 is actually 1, 2, 3 is right here, right in the shading. That's how we knew. We knew it was part of the solution, but now we definitely know it's part of the solution. Anything on the line is a solution to this inequality, and anything in the shading is a solution to that inequality. So for this one, we're going to ask you a couple questions because you can't graph this. You have to solve it for y. Okay. So hopefully you got a chance to tell us what the slope was for this particular problem and also what the y-intercept was. If I solve this for y, I'm going to subtract 3x on both sides. I'm not going to flip the sign because all I'm doing is subtracting 3x. Then I'm going to divide both sides by negative 2. When I do that, remember, what happens when I divide that by negative 2? All right, good. You are flipping the sign. This divided by negative 2. So that's just 3 over 2, but it's a negative divided by negative. So it becomes a positive 3 over 2x. And then 10 divided by negative 2 is negative 5. So now I got to graph y. I don't know why I wrote that as y. It's 2y. Y is greater than 3 over 2x minus 5. So the y-intercept is negative 5. I'm going to go up 3, 1, 2, 3 to the right 2, 1, 2. I'm going to go up 3 again, 1, 2, 3 over 2. And then because it's just a greater than sign, it's going to be a dotted line. Make sure you make it go off the graph so that we can really see it's a dotted line. And then where would the shading be? Well, hopefully you said the shading would be above the line. Now, looking at this, where are some solutions? Okay, so for example, I'm going to put this point right here. We'll call that point A. Okay, is that a solution? Okay, so good. Hopefully you said no because it's not part of the shading. And my next question is I'm going to put a point right here. We're going to call that C. Is that a solution? Okay, hopefully you said no because it's on the dotted line. If this was a solid line, then it would work. But really anything in the shading would be a solution to this inequality. All right, so here are two other ones. This we just want you to practice real quick. You could kind of make a makeshift graph. This is just for you to go ahead and practice these two. I'm going to do these for you pretty quickly. So y is greater than or equal to 4 would be a horizontal line because y, and it's a solid line because it's greater than or equal to 4. So where's all the stuff that's greater than or equal to 4? It would be all this stuff right here. This one I have to change into slope-intercept form. And try this first just so you can practice it. So if I change this, it becomes negative y is greater than negative x plus 2. And then I have to divide both sides by negative 1. So I have to flip the sign. And you end up getting x because you divide by negative 1 and you divide by negative 1. And you get y is less than x minus 2. So the y-intercept is negative 2. And it's a 1 in front of the x, so it goes up 1 over 1, up 1 over 1, and so on. And then it's going to be a dotted line because it's just less than, and it's all the stuff that is less than below the line. And there's your answer. All right, so what we're about to do now is you're going to want to kind of follow along. This is what we're going to do on the next couple of days. I'm going to ask you a couple questions in a second, okay? So first of all, I want you to think about when we have a system of inequality, it means there's not just one inequality, there's two of them. So whatever solution you have can't just work for one of them, it has to actually work for both of them. So what you're going to do is exactly what you did today. You are actually just going to graph each line, but you're going to shade them separately. And the answer is going to be actually where the shading overlaps. Let me show you. So y is greater than 4x minus 3. So the y-intercept's negative 3. And I'm going to go up 4 over 1. 1, 2, 3, 4 over 1. Okay, up 4, 1, 2, 3, 4 over 1. Okay, and it's a dotted line because, remember, it's not equal to, it's just greater than, okay? So we're going to remember for a second that this says y is greater than, so all the answers are going to be above. Now, I'm not really going to shade it. I'm just going to remind myself that the shading goes this way for this line. The next line, the next equation, I'm going to do in pink or red. It says that the y-intercept is positive 3, so that's right there, and that's negative 2 in front of the x. So the slope is negative 2 over 1, which means I could either go down 2 to the right one, or I can go up 2 to the left one. Either way, I'm going to choose to do this one. Actually, no, yeah, I'm going to choose to do this one because it's down 2. 1, 2 to the right one. Down 2, 1, 2 to the right one. Down 2 to the right one. Now, we don't care really where they cross. What we care about is we're going to graph both lines. So this is a solid line. Make sure you graph them like this. And it's still greater than, so it's going to be above the line. Well, if you graph everything above the line, it would look like this. So our solution to our system of inequality is actually going to be where they overlap. So where you see the blue line and the red line. So I'm going to go ahead and do, make it really dark and black right here. This right here is where where you see both the red and the blue. So any point in this black part right here would be our solution to our system of inequality. Now, a couple things to consider. One, because this is a solid line, it could actually be on this line, but it can't be on this blue line because the blue line is dotted. But it could be on this line or it could be anything in the shading. So whatever, like this point right here, whatever it would be, that's a solution to the system of inequality. Let me show you guys one more. So we did in class a lot of ones that say x and less than. So go ahead and answer this question. What would the line look like for x is less than or equal to negative 3? Okay. So hopefully you said a vertical line where x is negative 3 and it's a Remember, it's not a dotted line. It's a solid line because it says less than or equal to. So where is the stuff that's less than? Well, it'd be all this stuff over here. Now notice I'm not going to actually shade it in yet because we need to see where the other one is. Okay, so the other one is I have to solve this for y because you can't graph it otherwise. So I move over the 5x by subtracting 5x on both sides. And that leaves me with this. And then I'm going to divide both sides by 3. Don't flip the sign because it's negative 5 over 3x. I did not divide by a negative number. And negative 9 divided by 3 is negative 3. So now to graph this one, I go to negative 3, which is 1, 2, 3, down right over here. And then the slope is negative 5, 3. So I'm going to go, instead of going, I can't really go down 5. So I'm going to think of this as 5 over negative 3, which means I go up 5. 1, 2, 3, 4, 5. And then to the left 3. 1, 2, 3. Okay, and this is a solid line because it's greater than or equal to. So if it's greater than or equal to, which means that it's above the line. So where do you see both the black and the blue? You see it right here. So this right here, which I'm shading, is our final answer. Anything in this part will be our solution, but nothing here, no points here. The points have to be right in the shading. Okay. So we're going to do one quick one, one more real quick. Let's see if you can. I know that you might not have graph paper, but can you try to do this real quick so that you can see if you kind of understand the concept, and then it's very helpful if you do it first, and then you'll see if you get it right because I'll do it in a second. Okay, so pause the video and try this problem, and just you're going to have to kind of sketch it out. If you don't have a piece of graph paper. So hopefully you turned this point into y is greater than or equal to negative x plus 2, because I had to move over the x on both sides. I didn't flip the sign either. You didn't have to flip the sign. This one right here. So, to graph this one, you go up 2, and that's a point, and then I go down 1 to the right 1, because it's negative 1 over 1, down 1 to the right 1. And this would be a solid line, and it says greater than, so I know the shading would all be above it, but there's 2 of them, so I got to graph the other one. And the other one, if you change this one to y, you have y is greater than or equal to negative 4x minus 1. Well, negative 1 will be right here. And I would go down 4, 1, 2, 3, 4, and then to the right 1. Or up 4, 1, 2, 3, 4, and to the left 1. Either way, it is a solid line. And then the shading, it says greater than, so it would be above it, which should be like right over here. Notice though that even though the shading, there's no 2 shadings down here, all the shadings, if you look where the purple line and the blue line overlap, I'll go ahead and do this with a highlighter. It'd be right here in yellow. Oops, sorry guys. It'd be right over here. Any of these points right here. This is where the shading overlaps. So your solution to the system of inequality would be any point in yellow. So you could say, Mr. Katz, if I said, well, give me a point that works, you can say this point right here. That point is at 1, 2, 2, 1, 2, 3. So I know that 2, 3, because it's in the overlap shading, will work for both inequalities. So it's a solution to the system of inequalities. All right, we're going to do a little bit more of that on Thursday or Friday. So don't worry if you didn't fully get it, but it's just a preview.